Hey everyone, in this video, let's understand how we can find the total number of parameters in a deep neural network. So, for the sake of understanding, I have taken the same deep neural network which we have seen in the last video. So in this case, I have two input, so x1 and x2, and this x1 and x2 are connected to two neurons n1 and n2 in the first hidden layer, and on the second hidden layer, I have another single neuron which is called as n3, and the output from n3 neuron is the y hat, which is nothing but the output from my deep neural network. Now let's do one thing. So whenever we are training any deep neural network, one of the important thing is we have to find the right parameters for the given input. So before we begin or before we find those parameters, let's understand as how many parameters will be there in a deep neural network and how we can compute the total number of parameters in a deep neural network. So as we have learned already, in any deep neural network, two things takes place: activation and summation. So now for a single neuron, how many parameters does it have? Well, for a single neuron, it will have the weights equal to number of features of input. So if I have, let's say, two features, then in that case I'll have two weights, and for each neuron I'll have a single bias. That means one neuron, it will have one bias term. In my case, for the n1 neuron, I am getting two inputs. So two inputs are x1 and x2. Since I am getting two inputs, the total number of parameters are, it will have two weights plus one bias term, isn't it? So this is the total number of weights for the neuron n1. Similarly, for the neuron n2, it will have the same. So the neuron n2 will have two weights since it's getting two inputs and one bias term. Now I'm coming to n3. For n3, n3 is receiving two inputs from n1 and n2. So the inputs are h1 and h2. Since it is receiving two inputs, so I can say two weights, and this n3 will have its own bias term. So in total, I can say as this is 3, this is 3, this is 3. In total, I am having 9 parameters for this entire deep neural network. Now, if I want to say it in a common way, I can say as number of parameters is equal to number of input features multiplied with number of neurons in that layer plus number of neurons in that layer, because let me write it first and then I'll explain you. Number of neurons in that layer. Now using this formula, if I want to find the number of parameters in the hidden layer 1, using this formula I can write as how many input features I am having. In my case, I am having the number of input features as 2. And how many neurons am I having in the first layer or the first hidden layer? I am having the 2 neurons, right? So it is 2 plus 2. And what is the total number of neurons in that layer? It is 2. So in my hidden layer 1, I can say I am having, so 6 is the total number of parameters for the hidden layer 1. In the same way, using the same formula, I can find as total number of parameters for hidden layer 2. So for hidden layer 2, so for the hidden layer 2, how many inputs is it receiving? It is receiving 2 inputs. And so how many neurons is it having? It is having 1 neuron plus 1, which is nothing but number of neurons in that layer. So it is 3. So in total, including hidden layer 1 and hidden layer 2, I am having 9. Let's create a deep neural network like this in a TensorFlow and display the total number of parameters to verify our understanding. Okay, so since we'll be making use of TensorFlow in our class, so I'll access my TensorFlow. So I'll start by importing my TensorFlow like this. So I'll write as TensorFlow.keras. I'll import layers. I'll also import dense. I'll import model. I'll import models. I'll not import that dense will inside the models itself. So I'm importing layers and models. So to begin with, I'll start by writing as network is equal to models dot sequential. Okay, and then I'll add the layers one by one. So I'll write as network dot add layers dot dense, and I'll specify as number of units. So how many number of units am I having in hidden layer 1? I'm having 2 input neurons. So 2 activation is equal to, I'll write as sigmoid comma input 2. So this is the input that my neuron receives, and on my second hidden layer I'm having a single neuron. So network that add layers dot dense, I'm having single neuron as an output. So let me keep this activation as sigmoid. Okay, so I have built my deep neural network. So I'm sorry, so it is nothing but input underscore shape, I think. Yeah, okay, I have constructed my deep neural network. So let me print this summary of my deep neural network. So if I write a summary, see, it says on my hidden layer 1 I'm having 6, and on my hidden layer 2 I'm having 3. So if we compare to what we have found out mathematically, so this is what we have found. In the hidden layer 1 I'm having n1 and n2. So 3 plus 3, it is 6. So if I see here, see I'm having 6 over here, and on my hidden layer 2 I'm having 3. Okay, so formalize this. Number of parameters in a layer is equal to number of input features into number of neurons in that layer plus number of neurons in that particular layer. For hidden layer 1, 2 into 2 plus 2, 6. Hidden layer 2, 2 into 1 plus 1. So this is done. Okay, now let's do one thing, guys. So let me instantiate one more network. So to begin with, I'll write something like this. I'll write as network is equal to models dot sequential. Okay, and then in this case I'll write as network dot add layers dot dense, and in my this layer I'll say it as 5 units of neuron. Let's say activation is equal to sigmoid, and this takes the input of, let's say, yeah, this time I'll have 10 inputs. Okay, and for the second layer I'll simply copy this. Okay, and for the second layer let me put some more neurons, let's say 5 neurons, and this will have the activation as sigmoid. And on my third layer I'll put 2 neurons, and on my fourth layer I'll put a single neuron. Okay, so this is how I'm building my deep neural network. I'll just execute this. Now let's do one thing, guys. Let's find out what is the total number of parameters in this each layer, and let's verify it by printing the summary. Okay, so I'll copy this and paste it over here so that we can compute it mathematically. Okay, so this is how it looks like. So I have started by defining my models as sequential. Sequential is nothing but stacking one layer next to another. Okay, so for the first layer I'm specifying it as 5 neurons. So that means I'll have 5 neurons in my first layer, and the input shape is 10. So let's start by, I'll call this as layer 1. Okay, I'll call it as layer 1. I'll call it as h2, h1, h3, and I'll call it as y hat. Okay, so let's start by finding the number of parameters in the hidden layer 1. So for the hidden layer 1, number of input is 10 and the number of neurons is 5. So 10 into 5 plus, how many neurons am I having in this layer? I'm having 5 neurons, so 5. So in my hidden layer 1 I will be having 55 parameters. In the same way, let's calculate the h2. For hidden layer 2, how many input is it receiving? So the total number of input that it receives is equal to number of neurons in the previous layer. So for the hidden layer 2, the number of neurons in the previous layer is 5. So 5 is the number of input multiplied with 5, which is nothing but number of neurons in that layer, because 5 is over here, plus number of neurons in that layer is equal to 5. So this is nothing but 30 parameters, because 25 plus 5 is 30. And for the hidden layer 3, that is H3, let's calculate the total number of parameters. So how many inputs does it receive? So since I'm having 5 units in my previous layer, so this receives 5 input, and the number of units in this layer is 2. So 5 into 2 plus number of neurons in that layer is 2. So 5 2s are 10, 10 plus 2 is 12 parameters. In the same way, y hat, or the final output layer, so how many input does it receive? It receives 2. How many neurons does it have? It has 1. So 2 into 1 plus 1, which is nothing but 3. So if we calculate the sum, so this sum is nothing but 15. 15 plus 30 is 45. 45 plus 55 is 100. So the total number of parameters in this deep neural network which I have instantiated is 100. So let's do one thing. Let's execute the code and then verify whether it's correct or not. So I think there's a mistake, guys. Instead of network, I have written as metwork. So let me correct this. Okay, I hope everything is correct. I'll execute this cell and now print a summary. See, the total number of parameters in my deep neural network is 100. So it has 55 in the first layer, 55, 30, 12 and 3. So if we compare to it here, 55, 30, 12 and 3. In this way, we find the total number of parameters for a deep neural network. So formula is number of inputs does it receive, so number of input features into number of neurons in that layer plus number of neurons in that particular layer. So this takes care of weights and this takes care of bias. Okay, got it? Cool. So this was about finding the number of parameters in a deep neural network. In the next video, let's dig deep and understand more about the deep neural network. See you guys.